Hello everyone. In this video, we are going to discuss the second law of thermodynamics and its statements. It has two statements, law Calvin's statements and Rudolf Clausius statement. And we will prove that these two statements are equal. And first of all, we discuss the first law of thermodynamics. As we know that the first law of thermodynamics is the delta Q heat absorbed by a system is equal to the change in its internal energy plus work done. The first law of thermodynamics does not tell us that when this work can be done, but the second law of thermodynamics tells us that the conditions by which the work can be done by the system are on the system. Now consider the first statement, which is called Lord Kelvin's statement. It tells us that it is impossible to devise a heat engine which converts all heat absorbed from high temperature reservoir into useful mechanical work without expelling heat into low temperature reservoir. Let's understand this statement. It is impossible to devise a heat engine. We cannot construct the heat engine which converts all heat absorbed from the high temperature reservoir to mechanical work. For example, for simplicity, here we have a high temperature reservoir. It is a high temperature. Let's consider it is a high temperature reservoir, and there is a low temperature reservoir. Here is a low temperature reservoir. The low temperature reservoir is temperature T2, which is less than the temperature of high temperature reservoir, which is temperature T1. And if we construct the heat engine, let's suppose it is a heat engine which can absorb the heat from high temperature reservoir, the Q1, and do the useful work by this heat absorbed from the high temperature reservoir and no heat expelled to the low temperature reservoir. It is impossible to construct a device which can absorb the heat from high temperature reservoir but cannot expel the heat to the low temperature reservoir and do some useful work. And Lord Kelvin's statement tells us that it is impossible. Or we can also say that it is, if it happens, it will be a perfect heat engine which convert all the heat absorbed to the work done, and its efficiency could be 100%, which is Lord Kelvin's statement, according to the which Lord Kelvin's statement is impossible. We can say that it is this statement, if it happens, it would be a 100% efficient engine, efficient, perfect ideal engine, but it is impossible. And second is statement is called Clausius statement. According to this statement, it is impossible to devise or construct a refrigerator which by which heat can flow from low temperature low temperature reservoir to high temperature reservoir without expenditure of work. If it happens, there will be this refrigerator will be the 100% efficient, 100% efficient refrigerator, which is impossible according to the Lord Kelvin statement. Now consider here as a high temperature reservoir, and here we have a low temperature reservoir. We know that the heat cannot flow from the low temperature to the high temperature. It only possible if we devise a refrigerator here. The refrigerator will absorb the heat from the low temperature reservoir. It will absorb the heat from the low temperature reservoir, which is QL, and uh, expel the heat QH to the high temperature reservoir. And this process only possible if we do some work on this refrigerator. Without expenditure of work, it is impossible. And now consider the both statements are equal. To consider this, we consider the first heat engine and second the refrigerator, and operating between the two reservoirs, high temperature reservoir which is at temperature T1 and the low temperature reservoir which is at temperature T2. If we consider first of all our hypothesis, our consideration is uh, Kelvin's statement is incorrect. If the Kelvin statement's incorrect, and if it implies that the Clausius statement is also incorrect, then we can say that the both statements are equal. Let's prove that the Kelvin statement is incorrect and the Clausius statement is also incorrect. For this purpose, we consider the all the heat absorbed from the high temperature reservoir to the heat engine goes to work done. No heat transfer to the low temperature reservoir. If we consider the no heat transfer to the low temperature reservoir, this heat engine is a perfect heat engine which has the 100% efficiency. But according to the Kelvin statement, this is impossible and we construct this heat engine incorrectly. But if the Lord Kelvin statement, according to the Lord Kelvin statement, is incorrect, the Clausius statement is also incorrect, then we can say that the both statements are equal. Now, according to this refrigerator, the refrigerator is absorbing the work done from which is work done by the heat engine. This work done is absorbed by the refrigerator, and refrigerator will absorb the heat from the low temperature reservoir which is QL and goes to and extract the heat QH prime to the high temperature reservoir. This refrigerator is performing in Clausius statement. It is not a violation of the Clausius statement, but heat engine is violate the Kelvin statement. Now we overview of this process. Both process will be look like this: high temperature reservoir and low temperature reservoir, and some heat is absorbed by this system. Whatever this system is, we know that it is a combination of refrigerator and heat engine. This will absorb the some heat from the QL and goes some heat to the high temperature reservoir, which is the difference QH minus QH prime, which is the difference QH prime minus QH, and no work is done externally on this system because this work is done internally from heat engine to the reservoir. No work is done externally on this system. The work is done is zero. Now we are seeing that the heat is flowing from low temperature reservoir to the high temperature reservoir without expenditure of work. It is a violation of a Clausius statement. Here we consider that the Kelvin statement is incorrect. The Clausius statement is also incorrect. This implies that the Clausius statement is also incorrect. And from this discussion, we have concluded that the both statements are equal. This is QH prime minus QH. And first law, according to the first law of thermodynamics, if we apply it on heat engine, all the heat absorbed goes to the work done. And according to the refrigerator, the work done plus QL goes to the QH prime. And if we plug the values of work done in the equation of refrigerator, we will get the QH plus QL is equal to QH prime, and we can say that the QH prime is greater than QH. If the QH prime is greater than QH, this heat is greater than this heat QH. Now we can say that all the heat in this process, the high temperature reservoir, the heat is goes from the low temperature reservoir to the high temperature reservoir. Absorbed heat is less than this QH absorbed heat is less than the heat leaving to the expelling to the high temperature reservoir. Thanks for watching.